Hey y'all, for those of you who do not know, my name is Katie Harris, and today I'll be sharing with you all some statistical techniques for determining habitat selection. So to begin with, I'll start off with an introduction of my project and project methods, and then move into how this relates to a discrete choice analysis. We'll then conclude with the actual methods to carry out the analysis in RStudio. So wildlife management is a common practice in the natural resource field. Wildlife management commonly focuses on restoring ecosystems, balancing populations, and wildlife habitat improvement. However, this last one is an important one because you simply cannot improve an animal's habitat if you do not know the habitat requirements of that animal or the areas that it needs. So we know the requirements of many game species and even many non-game species such as the red-cockaded woodpecker. However, other animals have received relatively little attention in the literature, and the eastern box turtle is a great example of this. So it's important that we begin to explore this due to the current status of the box turtle. The eastern box turtle is currently listed as vulnerable throughout its range, and this is largely due to a combination of many factors, such as habitat fragmentation, road mortality, agricultural practices, disease, and even the pet trade and pet collection. These factors have contributed to more than a 50% population reduction in some areas. And this is an alarming trend when you begin to take into account many life history and natural history conflicts. So for example, box turtles are case-selected species in that they have a long lifespan, they have small clutch sizes, and they're slow to reach sexual maturity. They also have high nest depredation rates and high juvenile mortality as well. They also have many other natural history conflicts, and this increases their propensity to experience management effects, in that they are almost completely terrestrial. They have a fairly long active season and lack conventional dispersion methods, so they simply can't fly away or run away like many other species can. So to sum it up, box turtle populations are in decline due to habitat destruction, road mortality, and the mere biology of the animal, just like I mentioned. So therefore, the goals of my research are to develop management recommendations that can reduce the negative impacts on box turtles and hopefully aid in the conservation of box turtle populations. And a great way to start this process is to determine how an animal selects its resources. So to do this, I am using a discrete choice analysis. And a discrete choice analysis uses the logit model of logistic regression. And it determines a use versus available framework, and it attempts to describe, explain, and even predict choices between two or more alternatives. So this may sound a little confusing right now, but hopefully I can clear it up in a minute. I've also included a citation here that you can see if you're interested in this and want to look into it further. And then a big advantage of this statistical method in comparison to some others is that it allows you to conduct this analysis even though availability may change over time. And because of this approach is commonly used in economics. So many economists will use this model to try to estimate and predict consumer purchases or even investments. However, this approach can still be very useful in wildlife as well. And I'll go ahead and try to walk you through how the discrete choice analysis applies to wildlife. So a turtle, like all other animals, must make a choice of where to be on the landscape. And we'll know where each turtle is based on the telemetry data that we have. In this instance, this turtle chose his location, which is the green circle, over many other alternatives that he could have chose within the available matrix. So that turtle chose to be here, but he could have just have easily chose to be over here, or even over here. So simply put, he has a lot of options within this available matrix. So what a discrete choice analysis tries to do is it tries to compare that known location versus random locations within the available matrix. So these random locations are placed based on previous movement patterns and known average daily travel distances that were measured the previous season. So I'll go ahead and show you the data that we record at each of these points, both the known location and the two random locations. I'll bring that up in Excel. So at each location, both the known and random locations, we measure things such as the percentage of vegetation, as well as the proximity to aquatic resources, the litter depth, the canopy closure, treatments that they had experienced, such as if they were in a burned unit as opposed to not in a burned unit, or even broad categorical vegetation types, such as whether they were in a field or a forest. So by analyzing these parameters, hopefully we can determine if there's a difference between each known site and the random sites. So I'll go ahead and explain a little bit about how this data is set up as well. So to begin with, the stratum over here tells R what order to process the telemetry location of the individual animals over time. And this should be correlated with the choice column. This choice column determines whether it was a known location versus a random location. So here this is one telemetry measurement for a turtle. So its choice 1 is where the known location, where we knew it was, versus the two random locations. And then these stratum just go up by 1 in each instance. And this trend is constant throughout this whole Excel sheet. I also have the season over here. This could be important if we wanted to subset the data and see if there were any trends that were present over time or throughout specific seasons. And it's also important to note that these categorical variables are dummy coded, and in this instance dummy coding means to use a numerical indicator to designate the presence or absence of an animal. So if a turtle was present in an area, I would use a 100, whereas if it wasn't, I would use a 0. So you can see here that a turtle was not, or that this specific turtle was not in a field and it was not in a forest. However, here it was in a field and not in a forest. And you can see that continues throughout this data set. So now we can go ahead and move to RStudio, and I can begin to show you how this data is analyzed in RStudio. So I've already got the data in here, and we can check the structure. And we can change the structure, so the turtle ID number will need to be a factor. And then we'll check it again to ensure that that changed as it should, and it did. So the first thing we'll do is we'll start off by creating a null univariate model without random effects. So to do this, we'll need to nest 3 functions within one another. But before we can do this, we'll need to go ahead and install or load 3 packages. So we'll need to, I already have them all installed, so I simply need to load the mixed effects Cox model, as well as the survival model, which is already loaded, and then the multi-model interface that also needs to be loaded. So I'll try to walk you through this too to ensure you know what's going on here. So this Cox function fits a Cox proportional hazard regression model. And then this nested survival function here, it creates the response variable in our model. And then this REP function is the replication function. And it simply takes into account that we have multiple telemetry locations for each turtle. So once we have these three functions, we need to then input our time series, which is this 1 through 270. And that's simply the number of rows that we have in our Excel sheet. So we don't include the header, but we'll start here and start at 1 and see how many you have in your Excel sheet. So in this instance we have 270, which is why the 270 is there. We'll need to then include the choice. Again, that's simply whether the turtle was at a known site or a random site. And then we'll include the stratum, which I've already discussed what that was. And then next, we'll need to denote a ties method. And more than likely, and almost always in this type of analysis, you'll use the Breslow tie. However, if you're curious about it, then you can refer to the help file, and it's actually really helpful in letting you know which tying method you need to use. And then lastly, you simply need to set your data set. So then it's the moment of truth where you actually run it and pray you don't get a red error message. So we'll go ahead and run this model. Again, this is the null model. We can look at the outputs of that. By doing this. And this doesn't tell you much. So next I want to see if turtles are selecting burned areas versus unburned areas. And to do this, I basically use the same approach as the null model. However, I'll simply add burned here, which is a variable within the table. So we'll go ahead and run this. And then look at the summary of the output. So we have a very, very small p-value, and 0 is not included in our confidence intervals. So therefore, this specific model is in fact significant. And it's important to know that we can look at numerous other parameters within this model. For example, we can look at the litter depth by simply changing burn to litter depth, and then we can run that and look at the summary. And then we see that this model is in fact not significant. So if we look back up at the burn model, we see that turtles are selecting for burned areas when they're available to them. However, they're not showing any preference or selection towards litter depths. So simply the amount of litter does not dictate or does not predict whether a turtle may or may not be there. So we can continue this for other factors as well, such as coarse woody debris, which is CWD. And we'll change that here. And then run both of those. And we see that surprisingly, that is significant. So the amount of coarse woody debris is significant and does play a role in whether or not a turtle may or may not select for that area. So next I wanted to point out that we could also add a random effect into these univariate models. And the random effect that I'm using is the turtle ID. So simply each different turtle is included as a random effect within this model. So again, it's the same concept that we just went over, and we'll run this model. And again, that's the null model. And then this model here is the same burn model that we ran previously. However, we're including the random effect. So we'll see if anything changes when you have a random effect on the turtle ID. And then we'll look at a summary. And our p-value is still pretty small. So regardless of whether there's a random effect on the turtle ID or transmitter number, we see that turtles are still selecting for those burned areas more frequently than they're selecting unburned areas when they're available to them. So I also want to take a minute to bring up another method. I'll just briefly run through it, and it's a non-parametric method to determine resource selection with using the bootstrap method as well. So we'll have to load another package for this. This is the resource selection package. And this is similar to the last function we just run. However, we'll need to set it up just a little bit different. So again, we have that same choice field, the same stratum field, and then we'll add burned in there. That's the field that we'll be looking at. And then this here is simply the data source that you can see here. And then you'll need to have this M factor in here, and that M simply lets R know the random locations compared to the known locations. And then this B equals is the number of bootstrap iterations that you want it to run. So for this example, I went ahead and used 99. So we'll let that run, and then look at the output of that. And we can see here that it no longer is significant. So depending on how you run this and whether or not you used a non-parametric method versus a parametric method could greatly impact whether or not your results were significant. So with that, I'll conclude this webinar, and I hope you learned a little bit about discrete choice analysis and how to run that analysis in R. So thanks for listening.